Hello everyone, welcome back to our course. Next, we are going to introduce HBase, which is a distributed NoSQL database in Hadoop ecosystem. The basic definition of HBase says that HBase is a highly reliable, high-performance, column-based, and scalable distributed storage system. So from the description, you may have found that there are many good features of HBase. Firstly, high reliability. This is almost the same feature as HDFS because in HBase, we can also guarantee data replicas and HA mode. Secondly, high performance. This feature can be explained with this sentence here. HBase is suitable for storing large table data. And in addition, the reading and writing access to large table data can reach the real-time level. So from this sentence, you can find that HBase stores data in the format of large tables. But how large is it? Billions of rows and millions of columns. Such a big table could easily reach terabyte or even petabyte level. And moreover, the accessing latency is in real time, which means that you need only to wait for a few seconds before you get what you need from such a big table. Isn't it amazing? So this is the high performance feature of HBase. Thirdly, column-oriented or column-based. What does it mean? Column-oriented means that each column is a continuous entity, and data is read or written column by column. This is different from most of relational databases, for example, Oracle database, SQL Server, and MySQL, because they are row-based, which means that in SQL Server, data is read and written row by row. And as for scalable and distributed, again, because HBase is a part of Hadoop, so naturally, HBase has the same feature as other Hadoop components. And there are something more about HBase. We say that HBase is actually a database in Hadoop, and a database needs support from file systems. So we say that HDFS is used as the file storage system. That is, the data stored in HBase will eventually be flushed into HDFS. And finally, HBase relies on Zookeeper as the collaboration service because HBase also uses master and slave architecture. Just now, we mentioned one difference between HBase and RDBMS, and in fact, there are even more. Like what we can see from the table, for expenses or costs, usually RDBMS is more expensive. And because HBase is open source, it is very cheap or even free to use. Secondly, for data structure, RDBMS has a very strong and strict demanding on the table schema, which means that we need to predefine the table structure before inserting data into the table. And the table structure cannot be modified very easily. However, for HBase, it uses a key value model to store data, and new keys can be added at any time. So it is suitable not only for structured data, but also for unstructured data and semi-structured data. And for scalability, this is also a strength for HBase, because we know HBase is a distributed, share-nothing, NoSQL database. For RDBMS, it cannot be scaled out, and the space for scale up is limited. But for HBase, it is just developed to implement flexible horizontal expansion. It can easily implement performance scaling by adding or reducing the number of hardware in a cluster. And furthermore, data index. Data index is widely used in relational databases, and RDBMS can often build complex multiple indices on different columns to improve data access performance. So this is a strength for RDBMS. But for HBase, it has only one index called row key. We will introduce the concept of row key later. This is the only key for each row. And all access methods in HBase can be accessed by row keys or scanned by row keys, so that the entire system does not slow down. And as for data maintenance, we mainly focus on the multi-version property of HBase. Multi-version property is also a good feature for HBase. In HBase, new version of data will not override the old version of data directly, or namely, the old version of data can be retained. This is to prevent from errors like doing some updating by mistake, and we can do rolling backs more easily. So you may have already found that HBase is so powerful. Then, perhaps you are curious about what scenarios could HBase be applied to. In general, massive data storage. So please note that HBase is in fact a pure storage component which is not endowed with computing abilities. If you need to do data analysis, usually you need Spark or some other computing engines. And in this page, there are various application scenarios for HBase. For example, user image storage, message order storage, feed flow data storage, meteorological data storage, and so on. Feed flow is similar to social media data flow, and I will pick some of them to illustrate. Firstly, time series data. Time series data, such as sensor data, monitoring data, and stock K-lines, which is fit to be stored by HBase, since HBase features high concurrency and massive storage. Next, cube analysis, which is a kind of real-time reports, and so the raw data can be just stored in HBase for real-time reading and writing. And HBase can even satisfy other applications like NoSQL services and can be handled by secondary index and dynamic columns in HBase. Next, in order to understand the data model in HBase, we can have a look at the table structure first. In fact, this structure is a simplified one, which is just convenient for you to understand. Here, we give some concepts in HBase. We say that HBase uses tables to organize data. A table consists of rows and columns. Each row is identified by a row key, so we say that for each row, the row key is the only index. Besides, in HBase, there are concepts called column and column family. As indicated by the name, a column family is a family of columns. Or namely, a column family consists of several columns. In our slide, the info 1 is a column family with 3 columns as name, age, and gender. And info2 is another column family with 2 columns as salary and department. So the number of columns is not fixed in different column families, and also in different HBase tables, there could be one or multiple column families. Moreover, each column family is a continuous entirety, and different column families are stored in different physical files. In this case, a column family is also known as a basic physical storage unit in HBase. So we say that HBase is a column-oriented database. In fact, it should be column family-oriented. The intersection area of a row and a column is called a cell, which is easy to understand. And it is worth mentioning that in each cell, there could be one or multiple versions of data. In this page, the gender information for Jack is modified. So there is an old version, perhaps female, and a new version, perhaps male. Both versions can be kept in the same cell, which is just the multi-version property as we mentioned before. Again, this is to prevent from errors like doing some updating by mistake, and we can do rolling backs more easily. But how to distinguish the different versions? We can use timestamps for help, because there is always an older one and a new one. On top of what we have seen before, HBase implements more techniques to manage large tables. The first technique is called region. Simply speaking, a region is just a subtable which can be defined according to the continuous region of row keys. For example, in this page, the first 2 rows belong to the first region, and a third row belongs to the second region. So why we need region? Suppose that the table has 300 million rows. Then it may take quite a lot of time to locate one row out of 300 million. But if we divide it into 300 regions, and in each region there are 1 million rows as a part of the big table, now we just need to locate one region, which can be done with the help of metadata. Then we just need to locate the target out of 1 million, which improves efficiency by 300 times. And if we divide more regions, then theoretically, we can expect even higher efficiency. So in short, region is set up to improve the reading and the writing efficiency, similar to a chart in relational databases. And we define regions by cutting the table horizontally. And as we mentioned before, each column family is a basic physical storage unit in HBase. So in fact, the regions will be cut vertically as well. And the result of this vertical cut is called a store. In this page, there are 2 column families. So each region will be further divided into 2 stores. So a table with 2 regions and 2 column families has 4 stores in total. Alright, if you can understand what we have introduced before, then this architecture should be okay. Although you may find it quite complicated, but it has a very clear logic. So this architecture is also a master and slave architecture. where HMaster is the master node and HRegionServer server is the slave node. So HMaster is in charge of the whole HBase cluster, while HRegionServer server do the storage works. Each HRegionServer server here usually represents one server, and it manages all the regions allocated onto it. So here you can find the H region, which is just the region we mentioned before. And under one region, there could be one or multiple stores based on the number of column families. But here, maybe you have noticed a few more concepts. For instance, mem store. This is the store kept in the memory, because we know that I/O operations from memory is a lot faster than that from hard disks. So by default, HBase keeps data in the memory. But we know that data in the memory can be lost easily, so eventually the data is flushed into hard disks in HDFS. And the result is called a store file. And in HDFS, store file is implemented in the format of H-file. So you can simply regard that store file is just the same as H-file. And in order to guarantee high reliability, all the writing and updating operations will be recorded by HLog. And if there was something wrong or some data was lost, we can use HLog for data recovery. So that's all for HBase architecture. And finally, we can conclude this chapter by introducing the read and the write processes of HBase. Here we say that when you write data, the data is allocated to the corresponding H-region server for execution. This is what we call distribution. And this sentence is equal to say that regions are distributed to region servers. And in order to make sure the highest efficiency and highest reliability, data is first written to mem, store, and HLog. The commit invocation returns the data to the client only after the operation is written to HLog, because only after the data is recorded by the HLog can we say it will not be easily lost. And for reading, again, firstly, the HRegionServer server accesses mem store for highest efficiency. If the mem store cache cannot be found, the HRegionServer server searches store file on the disk. Alright, that's all for this chapter. In this chapter, we introduced what is HBase, some comparison between HBase and the relational databases, some application scenarios of HBase, the data model and architecture of HBase, and finally, data read or write processes of HBase. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.